All right, quick scenario. A company wants to modernize fast. Some workloads are global, some are legacy, budgets matter, and security can't be an afterthought. Leadership wants the cloud to enable the business, not slow it down. This is where architecture decisions really matter. The Google Professional Cloud Architect exam tests how well you can design secure, scalable, highly available solutions using Google Cloud, while balancing business goals, technical constraints, and operational realities. In this video, we'll work through practice questions that mirror the exam's real focus, choosing the best architecture, not just a working one. Let's think like a cloud architect. Question number 1. Your organization has a significant amount of log data stored in cloud logging. The data engineering team is accustomed to using SQL for analysis and wants the ability to create insightful dashboards for visualizing log trends and patterns. You want to follow the recommendations of the Google Cloud Well-Architected Framework to provide a solution for the data engineering team. What should you do? A. Enable log analytics and run queries in the linked log dataset in BigQuery. Visualize the data with Looker Studio dashboards. B. Create a log sync and export the data to a storage bucket. Create an external table in BigQuery for the data in the bucket run queries and visualize the data with cloud monitoring dashboards. C. Enable log analytics and run queries in cloud monitoring. Visualize the data using Vertex AL Workbench. D. Create a log sync and export the data to BigQuery using pub/sub. Run queries and visualize the data with cloud monitoring dashboards. Correct answer. A. Enable log analytics and run queries in the linked log dataset in BigQuery. Visualize the data with Looker Studio dashboards. Explanation. The Google Cloud Well-Architected Framework recommends using specialized tools for specialized tasks. Log analytics. This feature allows you to query your cloud logging data using standard SQL directly in the console. BigQuery and Looker Studio. By linking the log bucket to BigQuery, your data engineering team can use their existing SQL skills to perform complex joins. Looker Studio, option A, is then used to create high-level visualizations that are far more advanced than basic cloud monitoring charts. Why not D? While pub/sub to BigQuery works, it is more complex to manage operational complexity than simply enabling the built-in log analytics feature. Question number 2. You are designing an observability strategy for a new microservices application running on Google Kubernetes Engine, GKE. The application consists of multiple services, e.g. front-end, orders, payments. During load testing, you observe an error in the front-end services logs, but you cannot find the corresponding logs in the downstream services to investigate the root cause because the logs are not correlated. You need to implement a solution that allows you to follow a single user request across all microservices involved in the transaction. The solution must not require developers to manually add correlation logic to their application code. What should you do? A. Require developers to generate a unique correlation ID at the front end and manually add it as a field to every log message in all services. B. Configure all containers to write logs to st_out_st_dir, and then filter logs by pod name and timestamp the logs explorer. C. Implement Cloud Trace by ensuring the trace parent header is propagated between microservice calls to link logs to a single trace. D. Create custom metrics in cloud monitoring for error counts in each service and correlate incident spikes using a shared dashboard. Correct answer. C. Implement Cloud Trace by ensuring the trace parent header is propagated between microservice calls to link logs to a single trace. Explanation. To follow a user request through a maze of microservices, you need distributed tracing. Cloud Trace. By ensuring the trace parent, W3C standard header is propagated, option C, Google Cloud can automatically link logs from the front-end, orders, and payments services. Zero manual effort. Modern libraries, like OpenTelemetry, handle the heavy lifting of extracting and injecting these headers into outgoing requests, satisfying the requirement to avoid manual correlation logic. Question number 3. You created a cloud monitoring dashboard for your dev environment to view real-time application metrics. The ops team wants a similar dashboard to monitor the production environment. You want to minimize time and effort as you assist the ops team with their dashboard request. What should you do? A. Export your dashboard to a JSON file and share it with the ops team. B. Create a shared document and list every step you performed. Create the dashboard. The ops team can use the document to build their own dashboard. C. Grant viewer permission to the ops team in your project so they can recreate the charts in their dashboard from the console. D. Share your dashboard and send the shared dashboard URL to the ops team. Correct answer: A. Export your dashboard to a JSON file and share it with the ops team. Explanation: to replicate a dashboard across different projects, e.g., from dev to prod, with minimal effort, JSON export-import, option A, is the standard method. Portability. Cloud monitoring dashboards are defined as JSON objects. You can copy the JSON from the code editor or export it, and the ops team can simply paste it into their own project. Why not D? Sharing a URL only gives access to the existing dashboard in the dev project. It does not help the ops team create a new one in the production project that points to production metrics. Question number 4. You are designing a central, automated infrastructure deployment process toward your organization using Terraform and Cloud Build. The security team prohibits the use of long-lived static service account keys in any CI/CD pipeline. Additionally, while developers can propose infrastructure changes for peer review, they must not have permissions to directly apply changes in the production project. You need to design a secure and automated workflow for applying Terraform changes that meets the security team's requirements and ensures proper governance. What should you do? A. Configure the Cloud Build pipeline to use service account impersonation. Set up a trigger that automatically runs Terraform apply when a pull request is merged. B. Create a privileged service account and store its JSON key in Secret Manager. Configure the Cloud Build pipeline to fetch this key during execution to authenticate Terraform. C. Configure the pipeline to only run Terraform plan. After a pull request is approved, have an authorized developer run Terraform apply from a secured workstation. D. Use service account impersonation in Cloud Build. Configure the pipeline to run Terraform plan on pull requests and require manual approval before running Terraform apply. Correct answer: D. Use service account impersonation in Cloud Build. Configure the pipeline to run Terraform plan on pull requests and require manual approval before running Terraform apply. Explanation: security best practices in Google Cloud dictate that you should avoid static JSON keys at all costs. Impersonation. By using service account impersonation, option D, the Cloud Build service account acts as a more privileged Terraform service account only during the build. This uses short-lived tokens that expire automatically. Governance. Running Terraform plan on a pull request allows peers to review the exact changes before they happen. Requiring a manual approval step for Terraform apply ensures that a human gatekeeper validates the change before it impacts the production environment. Question number 5. You are deploying a critical application with a stateless, containerized, rented on Cloud Run, and a Cloud SQL Tor PostgreSQL backend. The application experiences unpredictable traffic spikes, and the business requires the ability to immediately roll back a failed deployment to the last known good state. You need to apply a deployment strategy that aligns with Site Reliability Engineering (SRE) principles for both the application code and the database schema updates, while meeting the business's requirements. What should you do? A. Configure the CI/CD pipeline to use the latest last container tag for deployments, with database schema changes applied manually as needed. B. Use a single CI/CD pipeline that first applies database schema changes and then deploys the new Cloud Run revision C. Separate CI/CD pipelines for database schema migrations from application deployments. When deploying a new Cloud Run revision, use gradual traffic split. D. Package the database schema migration script within the container to be executed on every container startup before the application process begins. Correct answer. C. Separate CI/CD pipelines for database schema migrations from application deployments. When deploying a new Cloud Run revision, use gradual traffic split. Explanation. In SRE, Site Reliability Engineering, the goal is to decouple components to reduce the blast radius of changes. Separation of concerns. Database schema migrations and application code should have separate pipelines. Option C. If a schema update is backward compatible, a requirement for zero downtime, the app can be rolled back independently. Traffic management. Cloud Run supports gradual traffic splitting, allowing you to send 5% of traffic to a new revision. If errors spike, you can immediately shift 100% of traffic back to the old revision. Why not D? Running migrations on container startup is a common anti-pattern in large-scale systems, because if 100 containers start at once, they might all try to modify the schema simultaneously, leading to lock contention or database corruption. The Google Professional Cloud Architect exam isn't about knowing every service. It's about proving you can design systems that support real businesses. Practicing scenario-based questions like these helps you. Think in terms of architecture, not components. Justify design choices clearly and confidently. Prepare for both the exam and real-world cloud projects. If you want more practice questions that match the exam's depth and style, check the link in the description for additional resources available on Cert Boosters. Subscribe to the channel for more cloud architecture and certification practice sessions. Thanks for watching. And remember, great architects don't design for today's requirements. They design for what the system must become.